Absolutely, there is life elsewhere, and almost certainly intelligent life. It has to be. The odds are just overwhelming. A recent revelation has sparked intrigue and wonder among scientists and space enthusiasts alike. Renowned science communicator Bill Nye caused a stir when he revealed that Voyager 1 had detected 300 massive objects in space. This revelation has not only piqued our collective imagination but also sparked profound questions. So, what are these objects, and where do they come from? Come along as we unravel the mysteries hinted at by Voyager 1's astonishing revelation. For nearly 50 years, the Voyager missions have given us some of the earliest and most remarkable views of our solar system's wonders. Surprisingly, these missions were not built to last so long. In the 1970s, Michael Minovich had a breakthrough idea: a spacecraft could use a planet's velocity to propel itself further into the solar system. Initially planned to last only 5 years, the Voyager mission has far surpassed these expectations. Voyager 1 and Voyager 2, launched just weeks apart in the summer of 1977, were first set to explore Jupiter and Saturn. They achieved this mission by successfully studying these gas giants, but they didn't stop there. Voyager 2 went on to make the first ever close-up observations of Uranus in 1986 and Neptune in 1989. These flybys of planets earned the mission the name Voyager Grand Tour. Instead of ending their mission, the resilient Voyager spacecraft set their sights on an even more ambitious goal: exploring deep space. Now, 46 years later, Voyager 1 and Voyager 2 are still traveling, gathering essential scientific data from the far reaches of the cosmos. In a groundbreaking announcement in 2013, NASA revealed that Voyager 1 had officially entered interstellar space. Interstellar space is the region between stars, beyond the influence of the sun's particles and magnetic fields. It's like moving from a busy solar system into a peaceful, star-filled wilderness. The Voyager story continued in 2018 when Voyager 2 also entered this vast region, 17.7 billion kilometers away from the Sun. Remarkably, Voyagers 1 and 2 are the only spacecraft to have ventured into interstellar space. These pioneering spacecraft have been studying how the interstellar medium interacts with the solar wind from our Sun. NASA's Voyager 1 and 2 spacecraft have been our primary source of information regarding the heliosphere, a protective shield enveloping our solar system. The heliosphere is shaped and adjusted by the solar wind, a continuous stream of charged particles emitted by the Sun. Voyager 1 and 2 have acted as our cosmic reporters, sending back valuable insights about this celestial shield. Where does all this information converge? At the heliopause, the official boundary of our solar system, marking the transition from the solar wind to the vast expanse of interstellar space. NASA's Voyager spacecraft has provided valuable new knowledge about interstellar space. One significant finding is that cosmic rays, mysterious particles, are 3 times more intense beyond the heliopause compared to within the protected area of the heliosphere. This difference is like comparing the tranquility of a backyard to the bustling activity of a busy street. However, there's more to this cosmic drama. NASA's experts didn't stop with Voyager discoveries. They integrated data from subsequent missions with Voyager's observations, creating a comprehensive portrayal of our Sun and its complex interaction with the surrounding interstellar space. In a grand cosmic performance, NASA scientists made a surprising revelation last year. Voyager 1 captured a low humming sound that matched the vibrations detected in small amounts of gas floating in the vast emptiness of interstellar space. Nicola Fox, the leader of NASA's Heliophysics Division in Washington, D.C., stressed the importance of the Voyager missions. In her words, over the past 46 years, the Voyager missions have been crucial in providing us with this knowledge and have changed our understanding of the Sun and its effects in ways that no other spacecraft can. Now, that's quite an adventure in space. Voyagers 1 and 2 rely on a power system fueled by plutonium. However, as the plutonium ages, it produces less heat, causing the Voyagers to lose power. Facing this cosmic challenge, NASA had to make tough choices, shutting down non-essential systems and even some initially deemed necessary. The heaters meant to keep instruments warm in the freezing expanse of space were turned off. But here's the surprise: despite the odds, all 5 instruments have been functioning well since 2019, defying expectations. NASA experts are puzzled, wondering how the Voyagers are still operating in temperatures that would normally freeze other spacecraft. It's a mystery that deepens the remarkable legacy of these brave space pioneers, adding another layer of wonder to their enduring journey. The outer edges of our solar system are surprising astronomers with unexpected behavior. The heliopause, which acts as a boundary between our sun's influence and the space between stars, is not staying still. Instead, it's moving and creating strange angles, leaving scientists amazed and puzzled. This idea of the heliopause changing shape isn't entirely new. For the past 10 years, smart researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite have noticed the heliopause's tendency to change. These spacecraft are incredibly important as they give us direct measurements of these cosmic borders, even though it's just at one specific spot in space and time. Dr. Eric J. Zarin, a space physicist at Princeton University, shared some exciting insights in an email to Vice. He mentioned how IBEX, another satellite, is adding valuable data to help scientists make better predictions about the heliopause's future movements. Now here's where it gets more interesting. Recent studies have challenged what we thought we knew. IBEX noticed a strange brightening of energetic particles, suggesting some irregularities in the heliopause. However, these irregularities didn't match our existing models, almost like a surprise twist in a story. Moreover, researchers saw significant changes in the heliopause's position in a short time after studying data from Voyager 1 and Voyager 2. This movement might explain why these two probes reached interstellar space in 2012 and 2018, respectively, with a big gap in between. These unexpected behaviors are not just confusing, they contradict what we thought we understood about the heliopause. In a recent article in Nature Astronomy, scientists referred to these discrepancies as entry-speaking, meaning they are puzzling and could cause some debate in the scientific community. But don't worry, the search for answers continues. Scientists are eager to learn more from NASA's upcoming Interstellar Mapping and Acceleration probe, scheduled to launch in 2025. This advanced satellite promises to reveal more secrets about the outer reaches of our solar system. Until then, we can only wonder about the mysteries waiting for us beyond the heliopause. In May 2023, Voyager 1 experienced an unusual event during its regular operations. The part of the spacecraft responsible for controlling its high-gain antenna, known as the Attitude Articulation and Control System (AACS), started sending back confusing data. Instead of the usual updates on the spacecraft's health and status, it seemed like Voyager 1 was having trouble communicating effectively, similar to how someone might struggle to speak fluently due to a condition like electronic aphasia. From our perspective on Earth, it appeared that Voyager 1 was experiencing electronic confusion. The data it sent back seemed random or lacked coherence, as NASA explained at the time. Interestingly, despite these strange reports, Voyager 1 appeared to be functioning perfectly fine. Its radio signal remained strong and stable, indicating that the antenna was still pointing toward Earth, contrary to what the AACS was indicating. Adding to the intrigue, Voyager 1 scientific instruments continued their operations without any issues, unaware of the anomaly in the AACS. Furthermore, the spacecraft's fault protection system, designed to respond to glitches by putting the spacecraft in safe mode, was not triggered by this event. Fortunately, NASA quickly identified the problem. It turned out that the AACS was using a computer that had been inactive for a long time. The solution was simple, a command to switch to the working computer for data transmission. However, the mystery remained about what caused the AACS to act strangely in the first place. NASA suspected that an incorrect command from another onboard computer might have triggered it. While this incident didn't pose a significant risk to Voyager 1's safety, NASA is actively investigating to prevent similar occurrences in the future. Voyager 1 has been exploring interstellar space for over a decade, outside the protective magnetic field of the Sun. This magnetic shield, similar to Earth's magnetic field, shields the spacecraft from cosmic rays and other space radiation, acting like a cosmic suit of armor. When it comes to technology, just as Earth's computers can face challenges from high-energy particles and solar radiation, Voyager 1's onboard computers also encounter cosmic hurdles. Sometimes energetic particles can interact with computer chips, leading to small memory errors that build up over time. Susan Dodd, the project manager overseeing both Voyager 1 and 2, provides a cosmic perspective on these challenges. She mentions that encountering such mysteries is part of the norm at this stage of the Voyager mission. These spacecraft have been on an incredible journey for nearly 5 decades, far exceeding their expected mission duration. It's worth noting that they are navigating through interstellar space, an environment filled with high levels of radiation, a territory no spacecraft has ever explored before. Nearly 50 years have passed since Voyager 1 and Voyager 2 set off on their remarkable journey. They've traveled across vast distances, delving into unknown realms and uncovering groundbreaking knowledge. These iconic spacecraft, now venturing into interstellar space, face a unique challenge. Their computer systems from the 1970s era operate with just 70 kilobytes of memory. Yes, that's right, a mere 70 kilobytes. Despite these technological limitations, NASA has successfully maintained the functionality of these distant explorers. Just imagine the effort of sending software updates across immense cosmic distances, akin to carefully adjusting the settings of a spacecraft over 20 billion kilometers away. Through these updates, NASA has optimized the Voyager systems, enabling them to continue their incredible journey of exploration. Their mission, initially aimed at understanding our solar system, has evolved into an even grander endeavor of interstellar discovery. Their instruments provide insights into a mysterious region between stars. While the Voyager's instruments have been diligently working to capture and transmit data, NASA acknowledges the inevitability of a cosmic event. In a few years, these brave spacefarers will lose their ability to communicate with Earth, leaving us with a sense of both awe and longing. Their final message, filled with data and discoveries, will mark the end of their incredible journey and a moment of reflection on the vastness of the cosmos. Yet, even after their transmission ends, the Voyager spacecraft will remain timeless explorers, forever drifting through the depths of space, a testament to human curiosity and our quest for understanding the universe's mysteries. Please feel free to let me know if you would like any specific details or alterations.